Hello and welcome everyone. My name is Mark Henry. I am a senior engineer with Opmantic's North American office located in Charlotte, North Carolina. Today we're going to be talking about how to support Harmony in the network monitoring group. So how to build dashboards for event storms or remediation that cover not just the networking team, but also the server team, and really speak more to user experience than they do to the individual pieces and widgets of hardware that are being monitored. As always, this session is being recorded. We will be sending out an email following the session to all attendees with a link back to the recording. You can also find this recording on Opmantic's YouTube page, as well as on opmantic.com under the Learn section. If you have any questions at all, please use the GoToWebinar Q&A window to submit your questions to us. We have a couple other engineers here with me who'll be monitoring that. They'll be responding directly through the Q&A window. And we'll also bubble some of those up to me, and I'll respond to them for the entire group. When the webinar is done, there will be a very short 3-question exit survey. Please take a moment of your time and answer that as truthfully as you can. We simply ask how well focused was the webinar? Did it meet your needs? How was I as a presenter? And then also, what are your thoughts and suggestions for future webinars? Today, we're going to focus on 3 different pieces. We're going to talk about how to retrain and focus your engineers away from hardware state and onto user experience. We're going to talk about how to leverage good dashboard design principles to support all stakeholders, and that's really the concept of a single pane of glass. And then the third thing we're going to talk about today are the 3 dashboards your team needs to build in order to improve performance by 30%. And that's really in cutting down the amount of time to root cause analysis. So today's webinar is going to focus on 2 different pieces. The first is NMIS, which is Opmantic's performance and fault monitoring solution. That's kind of the core of Opmantic's performance solution matrix. Everything pulls information from that. We're going to be focusing in on building dashboards using OP Charts, which is a commercial product which sits on top of NMIS and provides the ability to build really robust dashboards that interlink together and pull in information from other Opmantic solutions as well. A few references for you. Don't worry, you don't have to try to retype these from the video itself. You should have a copy of today's PowerPoint as a PDF in the downloads section. So if you look in the handouts panel on GoToWebinar, you should be able to pull a copy of that. If you're on YouTube, come to opmantic.com, look in the Learn section. You'll find the downloads there for this webinar as well. So let's start in on why we focus on user experience and not on hardware state. The first thing is to really understand the benefits of shifting from kind of a chaotic ad hoc model or a tactical approach to dealing with events on the network and moving that approach into a more strategic mindset. And what that does is if you look at that from the IT service management maturity model standpoint, you're really moving yourself from a level 0 and you're heading towards a level 4 of value as far as the performance and value that your group, that the network and server monitoring team brings to the organization. So as you move up through these levels, as you adjust the way that you do business, the types of software products you use, the types of processes that you implement, the way that you talk to your internal or external clients as well, and the way that you do business, you're actually improving and increasing the value to your organization. So let's talk for a moment about the concept of moving from a kind of a tactical network operations center to a strategic network operations center. And this speaks directly towards retraining your engineers to move away from that focus on CPU usage and memory usage and bandwidth usage, and instead shift to more of an overall understanding of user satisfaction. That, of course, is still built on all of those foundational components, all of those individual widgets and features and performance metrics, they all drive up to user satisfaction. But without understanding the total impact, again, really from start to finish, from left to right, for an application, you can't understand whether your users are getting the performance they really need out of the investments that the company is making. So the focus here from a strategic NOC level is really focusing in on user experience, user performance, application performance, and ensuring end-to-end quality of the network. And what that requires in many cases is the ability to conduct synthetic transactions. For example, logging into a SaaS web application, executing a command, having that command run through the application, push information into a database, pull information back out, monitoring the amount of time that takes, monitoring, did the information come back the way it was expected from the database, and then checking that from multiple geographic locations. So if you have offices, let's say in New York and in Florida and in California, running that same test from each of those three locations against that SaaS service, that SaaS application, and seeing what is the user performance, what's their experience. Are the screens drawing? Are they rendering properly? Are they rendering quickly? Is access to the database quick? Is it actually running that synthetic transaction in a way that makes sense? And then working backwards from the peak of that pyramid down into the guts and understanding exactly if it's not performing the way that you expect it to, or to user satisfaction, where is it falling short? Is it an internet service provider that's having issues maybe on the California office side? Is it the SaaS service provider that maybe doesn't have enough mirrored services across the country or globally? And then breaking down the information you have. Strategic NOCs really also focus more on automating initial fault response. So it's the concept of using something like Augmentic's OP events to do correlation, deduplication, handle event flaps, and then also be able to take proactive action and not just be able to do troubleshooting, like connect to a network device, run CLI commands, and capture the outputs, although OP events does that and does that really well. But it's also looking at a specific event and then determining what should happen. Should a service be restarted? Should a server be restarted? Does a routing table on a router need to be shifted and changed to change priorities on that router, so that you can reroute traffic to other devices on the network? So determining what can be done, what needs to be done, and then pushing the appropriate commands out or executing the appropriate scripts to do those types of things. And finally, one of the big key pieces of moving to a strategic organization really is also providing self-service, right? It's giving your clients, whether those are internal lines of business or external clients if you're working like a managed service provider, giving those users the tools so they can log into some kind of a portal and see, is the internet service provider meeting their SLAs? Do I have good bandwidth? Do I have enough hard drive space? Are my applications performing in the way that I need them to, so that they don't have to call the help desk. They don't have to enter in a ticket to ask a question about performance. They could come into a system and see that information on their own. So the benefits of moving from kind of a traditional tactical NOC to a strategic NOC model, you're going to reduce the time spent on routine responses, right? So engineers love that, rather than spending an average time of, let's say, 35 or 40 minutes responding to a ticket. If you can cut that by a third, if you can cut that by 50%, that frees them up and gives them more time to think towards improving the quality of the overall network experience rather than just fighting fires. It also helps improve the reaction time to user impacting faults, right? So these are things that understanding that a third-party provider like an ISP, being able to monitor that ISP and that ISP's bandwidth and execute synthetic transactions and keep track of those third parties that you may not be able to do performance metrics on their equipment, but being able to keep track on how well the data moves from, let's say, an office in New York to an office in San Diego, how fast that data moves back and forth between those circuits, and keeping track of that, and then generating alarms when that drops below minimum acceptable standards, can help improve your reaction. So rather than waiting on a client to say, "Hey, I'm having a problem downloading a file from the file storage system," instead of waiting for them to put that ticket in, you're actually getting proactive notification that there's an issue with the system. And of course, this all leads to reduced time to fault resolution, and of course helps you be able to predict outages and degradation of the system over time, because you'll be able to watch trending of performance. And if that isn't enough to really convince a working engineer that shifting to more of a strategic model and looking at things more from a user experience rather than from a small component standpoint is of benefit, just the concept of return on investment to the business, the concept that investing in a high quality performance and fault monitoring system like Opmantic Solutions built on NMIS and OP charts, the ability to take an operating SLA, improve that from, let's say, 97 to 99%, and then that of course reduces and generates revenue and productivity and savings just because you've reduced the downtime. So if you can just shift by 2 or 3 percentage points your downtime over a year, you can actually generate a tremendous amount of additional, I don't want to say new revenue, but generally cost savings to your business. So how do we do that? Where do we get to that point? How do we actually realize this concept of shifting from a traditional kind of NOC approach to a strategic NOC approach? And what does that look like when it comes to the products that the engineering team, right, whether that's people who are sitting at the call center, kind of your first line of defense, or whether that's the tier 2, tier 3, tier 4 engineers who are really digging into problems, digging into performance issues, looking at the configuration of devices and address tables and BGP and OSPF and those types of things. So when it comes to designing better dashboards or better user experiences, we really start talking about the concept of a single pane of glass. And before we can drill into that, let's just have a definition that we can all start from. So really an effective single pane of glass brings disparate sources of data together to give you a big picture of a system. So it's not just red light, green light on devices. So it's not just looking at a list of devices, routers, switches, hubs, firewalls, servers, and saying, are they up or are they down? Instead, it's looking and pulling in things like net flow and IP fix data. It's pulling in trending information about the performance of interfaces. It's overlaying events that are happening against configuration changes on the network, and laying those pieces together and putting them together in a way that, whether it's an engineer sitting at their desk, pulling the application up on a monitor and having that run on the side so they can kind of keep it in the corner of their eye, or whether it's up on the big wall, for everyone to see in the NOC center. Designing systems that are cross-functional and that speak to several different data streams is instrumental in providing that single pane of glass. So there are really a handful of benefits that come out of moving your dashboards to a single pane of glass view, pulling in information from multiple systems. We've picked just a few of them here, right? So they lead to increased visibility, right? If you can pull in data from more places, you can put it all together, you can correlate it, you can show it trending against other performance metrics. You improve your visibility, right? You can reduce operational complexity. People aren't having to deal with multiple disparate systems, especially if you can pull them all into common interfaces, common ways of working with the data, common ways of configuring the different types of applications. And of course, that all leads to reducing time to root cause analysis. And we talked about that a bit before. And really, that's all, the heart of that is removing silos. So it's not the network group against the server group, against the storage team, against the third-party data center provider. Instead, you pull all that information together. So you remove the silos, you remove the differences between those groups. You allow each group to see what's happening in all of the value chain of the applications that drive user experience. So you get rid of those silos, you merge in all technologies, all vendors, all operating systems within a kind of a single place, right? So there are some rules to putting together really good single panes of glass. This is my top 7 rules. These are the kind of the things that we teach when we do an implementation, we do a training session. Generally speaking, if clients are implementing our network performance and fault monitoring system, NMIS, along with OP charts and OP events, that's usually a 3-day training session. We cover each application for a full day. And when we talk about OP charts and building single panes of glass, we focus on these 7 rule sets. The concept that any individual dashboard should have somewhere between 5 and 7 groups of data at most, right? So you don't have to have 5. I've built really usable dashboards that just have 2 panels on them that are really, really well done and really usable because they focus in on answering a question. Number 2, you want to be able to group layouts. Need to be organized by data, time period, or visualization. So for example, you don't want one chart that covers 15 minutes, but then the chart right next to it covers 3 days. Because if they sit next to each other, users will expect them to cover the same amount of time. No group should have more than 5 to 7 data sets. You'll see when we go into OP charts in a minute, you can actually very quickly and easily stack multiple data sets together within one graph, within one chart. And you want to be careful, just like the big rule of how many components you put on a dashboard, you want to be careful of how many things you put inside a chart. Because depending on the resolution of the monitor that's shown on, or the ability of the user to distinguish the data that's within that chart, you can easily overwhelm people. Next, each data set should be easily distinguishable from other data sets in the group. And a lot of times that's simply just using color coding, right? And so that kind of ties in with number 5. Similar data sets across groups should use similar colors and icons, which means that dissimilar data sets should use dissimilar colors. So if you have one metric that's monitoring CPU usage and you have one chart that's monitoring response time for a web service, they shouldn't be drawing those lines in the same color. Because when you look at that chart, and we'll give you an example of that in a minute, a human will assume that those colors mean similar things. So again, that even ties in with number 6. So 4, 5, and 6 are really very closely related. I do like to leave them separate because there are nuances that are there. But number 6, colors and shapes should be used with purpose and definition. So whether you're using a line chart, a bar chart, a graph, a stacked graph, you might be using a pie chart, all of those shapes should be used with a purpose and with a definition. You're selecting that way of displaying data because it means something. And then finally, and this one, number 7, I've gotten to very heated debates with engineers. Many will understand that if a dashboard is being displayed on a big board on the wall, that you don't want to have to scroll through that dashboard, because that big board is generally static. People don't touch it. People don't necessarily interact with it. It's up there to show the overall status of the network or of the whatever's being worked on at the moment, whatever's being troubleshot at the moment. And so users shouldn't have to scroll through that and change the visualization, because if I'm scrolling through that dashboard looking for something, and there are 20 other people that are looking at it at the same time, they may not want to have me changing what they're looking at. So most engineers will understand that approach, but then they'll say, well, for my dashboard, if I bring it up on my desktop, I want to be able to scroll through it. My argument to that simply is if you have that information up on your dashboard and you have to scroll through it, what you should do instead is build a second dashboard that you could page to separately or put on a separate monitor. And the reason for that simply is that the data that's off screen that you have to scroll down to may contain critical information that you miss because you don't scroll into it. So let's take a look at an example of a bad dashboard. So this dashboard has an awful lot of stuff going on with it. Each of these panels that are here are we call widgets. So they're all widget panels, or components inside OP charts. So you have a dashboard that's a large container. A dashboard is made up of components. Those components could be geographic maps, like the one in the top left corner. That's actually a Google map with some devices and some groups of devices, and then a linking line between it. It could be made up of chart components, like the one in the top center. It could be made up of top-end reports, like the ones at the top right and center right. It could be topology maps, like the one in the bottom right-hand corner. You'll also see that there is a monitored services panel in the center left and center of this dashboard. And then there's a couple of more charts down in the bottom left corners. And then in the bottom center, there's a very complex stack of CVQoS graphs all overlaid on each other. So first of all, there are too many groups. So if you count up all these panels, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. We've got 9 panels in all. That breaks our 5 to 7 maximum, right? And 5 to 7 is really, again, if you can keep it less than that on an individual dashboard, you're better, generally speaking. And you really only want to go up towards the 7 end of that range if it's easy visually to interpret all the information. This also suffers from poor grouping, and the reason I say that is that you have multiple. You have a chart up here that's a specific service status, and then you have a server status down here, or you have a service status, excuse me, and another service status here. So from the very least, those 3 should probably be grouped together. There are too many data sets. So this one chart, for example, there are something like 15 different data sets that are charted in that graph. And so it's almost impossible to read them at this resolution. There's also a tremendous amount of time here. There's one day, there's 24 hours in that graph. And so left to right, just horizontally, there's so much data that's being displayed that it's impossible to understand what you're seeing and be able to drill into it. We mentioned that these 3 are too similar. So even though they're slightly different, so the 2 in the bottom left corner, those are monitoring responsiveness of different services. So Test Telstra, that one's actually checking the ISP connectivity service from our Brisbane office to the local ISP Telstra. And then the one right next to it to the right, the Google service response, that one's actually reaching out to google.com. It's loading that page and it's waiting for page load, and it's making sure that Google is responding. But that's actually coming back from a different test point. So the test point on the left is coming from our Brisbane office and the ISP there, whereas the Google service response is actually being tested from our offices in Charlotte, North Carolina to Google. So they're similar, but they're dissimilar enough that these 3 should be probably located together as far as the poor grouping number 2 goes, but they probably should have different colored charts. You'll also notice that these cover different amounts of time within the windows that are there. This one in the top left, you'll notice this one doesn't fit. So part of the drawings here, part of the icons for the health of those 2 different offices are drawing outside the boundary box of that component. So things aren't fitting properly within that window. And then all 3 of these panels require scrolling. Now, generally speaking, I really usually prefer that an entire dashboard itself, that the dashboard as a whole doesn't scroll, but also that components within the dashboard. So the monitor service, for example, you can see that this the scroll bar is really at the top, and there's an awful lot of space down here, which means that there's a lot of data that you're not able to see. And you're probably missing at least a half dozen here. So if this is the top 10, you've got 6, so you're missing 4, and so you're missing 4 here as well, right? And again, anything that you can't see in the dashboard is something that you could miss that could be an important consideration for you. All right, so how do we actually design a dashboard? So we've got a set of rules now. We know what things should be done on an individual dashboard, but how do we actually create dashboard views that impact us and support the concept of a strategic service rather than a tactical service. So I like to lay this out left to right. Some people want to do it top to bottom, more like a pyramid. You know, whatever works for you mentally, whatever paradigm works for you. The concept here is that you create at least 3. Some people will do 4 levels of abstraction, where level number 1 is a very abstracted 50,000 foot view. In many cases, users will create that as some kind of a map. Now, don't misunderstand. The term map could mean a geographic map, right? A physical geographic map of the United States or the globe with different office locations and connection lines for your ISPs in between those. Many people start from that approach. A map could also very well be a topological map. So you might create a topological map of all of your edge devices, how they connect together. You might have a topological map of all your core devices, how they connect together, all of your redundancy, all of your linking lines in between those. So you can kind of watch how all your devices are talking to each other, how they're working with each other. The concept here, though, again, is that you're staying at a very, very high level. You're not necessarily drilling down individually into an individual device and looking at one device and saying, how well is this one device working and health performing? Instead, you're looking at much more of a forest view rather than a tree level view. The second level to that is being able to go from that high level and then connect down into something that is at a medium level of detail. So this might be more of a going from a large geographical map of, let's say, the United States down to a network diagram of, for example, the Charlotte office. So that network diagram might be a topological map of the Charlotte office, their components, the lines that come into it, maybe even a physical map of the Charlotte campus. And again, I'm using Charlotte because that's where our offices are located here on the eastern side of the US. But it might be a geographical map of your office or of the buildings and all the interconnection points within there. And then you might break down the services as well. You might have a couple of different dashboards at that level too, that also, beyond breaking down the building by building, location by location, or topological maps, you might have service statuses as well. You might take and do some synthetic transactions through applications that are either supported or required to support that regional office. And then that way you can go from the abstract to the more detailed, and then go from that more detailed more down to the device level. And notice that this breaks out things like device details, it separates fault details, and then we separate configuration detail as well. And this is just a logical thing, right? So it's providing links and connections to be able to go very, very quickly from a high level and abstract understanding of what's happening across your entire organization, go from that level, see that something is not green, something has gone from less than perfect performance down to something else, and then drill into that and go down to a regional or a service level and look at that, and then be able to go from that level very much down at that point, at that level 3, down to the device level, right? And say, oh, it's this interface is having bandwidth issues. This device is not dealing with its lost its BGP peer connections, so that's not working properly. Oh, these devices over here, they've got low memory availability and high CPU usage. It's overloaded, and we need to keep track of that and maybe look at spinning up additional resources or adding more resources to that device. So let's take a look at what some of these look like. I'm going to switch over to OP charts now. All right, so this is the standard OP charts nodes view. And one of the first things I want to give you a concept of is something that we've just added recently in with the release of, I think it was OP charts 3.2.6. So that came out about 2 months ago. We've just recently released OP charts 3.3.0. But it's this concept right here, this view and geographical map. So you'll notice over on the left-hand side, we have this filter assembly. The concept that you can take all of your devices that are in OP charts and you can filter them out. You can apply some kind of filter rule to them. So whatever I want to filter on, so for example, if I want to say, I really only want to see everything that is part of the e-commerce business service, it'll break it down and just give me those devices. And now if I click View in Geographical Map, it'll create a geographical map. It'll map these devices out to it. You can see that 3 of these devices are all in the cloud location, and one of them is in Surfer's Paradise over in Australia. I'm going to adjust my filter over here again. I want to see everything in my company, and I'm going to hit View in Geographical Map. Now what this is going to do is it's actually going to create an auto updating map for me. It's going to generate the map. It's going to save the map. I can edit the map. I can make changes to it. I can add to it if I want to. But OP Charts is actually going to maintain this map for me. What that means is as new devices are added to NMIS and those devices are assigned to a location, every time this map updates, all of these states that you'll see. So for example, as we zoom in, let's zoom in here to the East Coast office. You'll see here that this is marked actually as degraded. You can see the name down here. If I click on that, it'll zoom me right into it. It'll show that I have 2 setups. So there's one up here at the East Coast Google data center, and then we've got Charlotte itself. I can blow that up, and I can see the 4 devices here in Charlotte, and I can click on each of these, and so I can very, very quickly, without having to actually physically build those multiple levels, I can have those multiple levels immediately just from this auto-generated map. And again, this will auto update. And if I had used that filter to filter down on, let's say, a specific location or devices that are assigned to a specific service, or if I'd even created a custom filter, let's say SLA, service level agreement, I might create a service level agreement filter and then say, you know, I only want to see the devices that are gold level, and then I want to auto add those to a map. And so I want to have a map for my VIP customers that have gold level status. And so you can do that. And you can do it with a couple clicks, and this is saved now. And so I can add this. I can actually make this my dashboard if I want to. And again, that gets me right down into the heart of how the devices at that physical location are doing. So that's one option for me, rather, to build a map at that very, very high level. Now, again, if I want to, I can go back to the nodes panel. And I can do very much the same thing with view and network map. So I can take all of my devices and be able to view them all at one time. But remember now, if we're going to build something that's at a very, very high abstract level, you don't necessarily want to see every device all at one time. So I might use something like node role. So for example, I can come in here and I can say, I just want to see the things that are stacked as core, that are marked as core. There happen to be 35 of them. I might look at SLA, and we happen to have an SLA here, and there are 15 devices that are labeled core devices. And I also want to see the ones that are gold devices. So now that's cut me down a little bit further. So I'm going to view those in network map. That's actually going to create a topological map for me now. Now from here, I can decide what I want to see. Do I want to see subnets? And I could leave this alone. I could change the way that this is laid out. We can do this as concentric circles. I can change the layout a little bit if I don't like the way it looks. We certainly add more subnets, connect these devices together. So now we're getting a bit more interconnectivity between it. Looks like we've got everything except for the demo server added. Let's add the demo server subnets in here as well. And I'm not really liking that concentric circle, so I'm going to change it to a cola layout. There we go. So now we get a bit of a spring form thing happening here. All right. All right. And see, now I can sit here and figure out what makes the most sense for me. How do I want this to look? How do I want to save this? We can turn off auto layout so it doesn't redraw the screen on us. And now I could save this, and I can make this my my core gold SLA device map. And this might be either my top level, a top level component that I make available, or it might be a component that that I add at that second tier. I'm going to go ahead and add that in now. So let's call this core gold. So that's the map name. So I'm going to call this core devices with gold SLA. I'm going to go ahead and save that map. And if I want to, of course, I can, we can play with this even further. We can move these devices around, whatever makes the most sense as far as visual layout goes. The system is very, very flexible that way. And if we want to, we can close up a little bit of graphical space here as well. All right, I think that's good. Let's go ahead and save that. And now what I want to be able to do is I want to actually add this to a dashboard. So I'm just going to click the little submenu button in the top right corner, and I'm going to hit add to dashboard. I'm going to tell it I want to build a new dashboard. So it's going to add that component to the dashboard, and I can pick and choose how big that component is. And I want to make that dashboard a little on the wide side here so we can get a good look. And I want to add one more component to this. So I just want to have two little pieces on this dashboard. I'm going to let these two things take up a bit of space. And this one on the right, I can add different types of things. So we can add business services, right? Again, if we're thinking that top level, I want to add some business services. Do I want to add charts? Do I want to add information about collectors from Open Audit? Do I want to add specific maps of different types? I can add a geographic map if I want to. I can add things like events if I want to here as well. So let's go ahead. I'm going to add an actual map, and this is a map that I built earlier today. So we're going to look through here. So I actually have a map of our office area here in Charlotte. So I reached out to the management company, Atapco, and they were kind enough to give me a couple of graphics. So we just assigned that as a background, and so I'm going to just call this the Charlotte Core Gold Dashboard. And I want to add this to the operators group so I can actually have a group of dashboards and I can cycle through those dashboards. Now this is going to drop me off on that dashboard, and so I've got the nice topological map on the left-hand side, and then over on the right-hand side I have more of a physical layout. So if I have engineers who aren't familiar with the office layout here in Charlotte, who are wondering where these components are, so perhaps these devices on this side of the topology map might map to this one building, whereas devices on the other side might map to the other building. So again, it's just providing something in context that makes sense. Now, from my perspective, I would probably call this a mid-level dashboard, but you could absolutely create much higher level. So for example, from the operators selector here, here's that view from a much higher standpoint, right? So we've got that breakout, custom views here. Over on the right-hand side, I've got more of a drill down into a regional aspect. That could absolutely be a map of the United States or a global map with the weather overlay on it. But we've got live components here as well. And then at the bottom, we have a breakdown of events happening across the entire network. Or you might do something more like a breakdown into a specific building. So from that high-level map, I might have links that go down, for example, to an individual building like this one, where I can zoom in and out and then look at the performance of devices within that building on specific floors, or the links that are between those points. Same thing for the floor plan as well. It all comes down to understanding, again, and focusing in on the pieces of the puzzle that make sense. And we don't want to forget the concept of moving away from necessarily individual devices and looking at things like monitoring services using synthetic transactions. So in this example, you'll see here that we have a service monitor. So we're actually running synthetic transactions through a web application. We're monitoring that for performance. How much time does it take that synthetic transaction to execute? And then if it takes longer than 2.5 seconds, we set a threshold and generate an event from that. And at the bottom, we're also monitoring, again, a local ISP to our offices out of Brisbane, Australia. So our ISP there is Telstra, and we're actually loading a test page that Telstra provides for testing their service performance. And then down the right-hand side, we have several different business services. So we have some different monitored services that are being done. We have some interfaces we're keeping track of, and then we have overall device health. And yes, this little panel is breaking my no scrolling rule. That happens to be because of the screen resolution I have set up for this GoToWebinar. But normally it actually renders without a scroll window. Otherwise, that could be resized. So whether it's building these types of pieces or interconnecting them. So the concept, for example, here's this dashboard again, and here's a couple of different looks. But you'll notice down here, this is a link actually to go from this high-level view to a more refined view of this device. And so I can actually drill into that, and that'll actually take me from this view to a floor level view of that building and our offices in that building. All right, I want to thank you all very much for your time today. If you have any questions, my email address is markh@augmantic.com. That is my cell phone number as well. I do return every call I get. Happy to talk to any of you, answer any questions you have. I'm a working engineer, just like many of you are. So I'll field those questions as I can as an engineer, not as a salesperson. So thank you again. I look forward to seeing you at one of our future webinars.